Hi, today I'm going to talk about the binary number system. All digital electronics uses the binary number system. You've seen it somewhere, a bunch of zeros and ones in a string. And it really just means a one is a high electronic signal or a one on. Zero is a low ground signal, which is also a off signal. So 0, 1, off, on, low, high. Same ways of saying it. To understand the binary system, we got to understand the own system. So we use what's called the decimal system. That's what we're familiar with. And it's base 10. So basically, that means that each digit can represent 10 different numbers, 0 through 9. So when I was born, my first year, I was 0 years old. I was 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 different numbers with one digit. Okay. When I reach the end of that sequence, I just start over and I add one to the next sequence out, right? So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. When I'm at the end, I add to the next one out, it would be 20. So that's how our number system works, base 10. So what we probably never thought about is, for example, I was born in 1968. 1968, right? So if I look at it, these are the ones, these are the tens, these are the hundreds. I don't know why I put the S up there. Ones, tens, 100s, and 1000s. So basically, I have 1,000 plus 900s plus 6 tens plus 8 ones would be 1968. Okay, check it out. What was the base of our system? Base 10, right? So where do these numbers come from? 10 to the 0 is 1. 10 to the first power is 10. 10 to the second power is 100. 10 to the third power is 1000, and so on and so on. So base 10, each digit is, that base to a certain amount of power. So 0, 1, 2, 3, and so on and so on. Okay, so let's start counting in binary, and then we'll go back and learn how this really works. And I'll do another video with how to convert back and forth. Okay, so check it out. 0 in decimal. In binary, we have 2 character. So binary is base 2. So think about bi. What does bi mean? I have a bicycle. It has 2 wheels. Bi means 2. If you are, nowadays you could be bisexual, you like 2 different sexes. So bi just means 2, right? Okay. So each digit can be presented with 2 different numbers, a 0 or a 1. So a 0 in decimal, what should we call that in binary? How about 0? Okay. A 1 in decimal, what should we call that? Let's call it a 1. So 0 is 0, 1 is 1. Okay, but what about 2? Now I'm at the end of my sequence. In binary, I only have zeros and ones. So I'm at the end. What do I do? Okay, remember, whenever I get to the end of a sequence, I just start over and I add 1 out in front of it, right? I count out to the next. So I go back to 0 and I add 1 in front of it. So 1, 0 is 2 in binary. 3, okay, now I can go back to this guy. 1, 1 in binary is the same as 3. Okay, now I get to 4. What do? I can't go any higher in my 1 option right here. Okay, so I go back to 0. I can't go any higher on this guy. I'm already at 1. So 1, 0, 0. would be 4. Okay, now I can go over, so 1, 0, 1 is 5. So 1, 0, 1 is 5. I can't go any higher, so I got to go back. I can go higher here. 1, 1, 0 is 6. 1, 1, 1 is 7. Now I'm at an 8. I can't go any higher. 0 can't go any higher. 0 can't go any higher. I add 1 out. 1, 0, 0, 0 is 8. 1, 0, 0, 1 is 9. 1, 0, 1, 0 is 10. 1, 0, 1, 1 is 11. 1, 1, 0, 0, 12. 1, 1, 0, 1 is 14. 1, 1, 1, 0 is 14. And 1, 1, 1, 1 is 15. If I was to go to 16, I would go another one out. 1, 0, 0, 0, 0, 17, 1, 0, 0, 0, 1. Bam. So there we have it. That's how we count in binary. So check it out. Just like we had 1968, it was ones, tens, 100s, 1000s, or really 10 to the 0, 10 to the 1, 10 to the second, 10 to the third. Okay, if I take any binary number, let's do 1, 0, 1, 1. Okay, so these guys, my base is 2, right? So this guy would be 2 to the 0, 2 to the first, 2 to the second, 2 to the third. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third, 2 times 2 times 2 is 8. So basically, instead of being ones, tens, 100s, and 1000s, in binary, I have 1, 2, 4, and 8. So if I want to convert, right, back in these guys, I add up what I have. I have whenever I have a 1, I have that character. If I have 0, I don't have. So I have an 8. I do not have a 4. I'm going to write it a little bit better so you can see it. So this guy would be the 8, 4, 2, 1. Yeah. Okay, so I have an 8. I don't have a 4. I have a 2. I have a 1, right? 8, 9, 10, 11. So 1, 0, 1, 1 is the same as 11 in our number system, base 10. So if I go 1, 0, 1, 1, 1, 0, 1, 1, same as 11. Okay, let's do another one. Let's erase these guys really quick so you can see if I can find my eraser. Let's take another one. Let's do 1, 1, 1. I'm going to write it in black so you can see it better. 1, 1, 1. 1, 1, 1. So in binary, what is 1, 1, 1, right? So the first digit are the ones. And it's the ones because that's 2 to the 0. Second one are the 2s. That'd be 2 to the first power. Third one are the 4s. That would be 2 to the second power. So now I have 4 plus 2 plus 1 is 7. 1, 1, 1 is 7. Okay. Or if I do another example, one, 1, 0, 1. Okay, what is 1, 1, 0, 1 in our number system, right? So I go 1s, 2, 4, 8. So I have On this guy, I have 8 plus 4 is 12. I don't have a 2. Plus 1 is 13. So 1101, 1101, 13. So pretty easy to convert back that way. Okay, so check it out. As I go out larger in binary, right? 1 0 1 0. I did the opposite. 1 1 0 1. Okay. Let's say that I have, this is a binary number I need to convert. So the first digits, 1s, 2, 4, 8, they double every time I go out. 16, 32, 64, 128. So if I go further out, 256, if I had even a bigger number, 512. So if you ever had to buy memory for, like, let's say you are buying memory for a computer, or you're buying a memory card for a camera, anything like that, if you have, it's always 512 gigabytes, 256 gigabytes, 128 megabytes, 64 gigabytes, 32, whatever. It's always these numbers right here, because that's how many output pins you have. Okay, so these guys will dictate, these numbers will dictate the size of your memory, because that's how many pins you have available. So for example, if I had this long number right here, that would be the same as 512. I don't have 256. So let's go here, 512 plus 128 plus, I don't have 64, plus 32 plus 16 plus 8 plus 2. Okay, so let's see. I have 10, 20, 28. I have 2, 3, 4, 5, 8, 9, 5, 6, 698. So this binary number right here would be the same as 698 in our number system. All right, so check it out. Something that's interesting in these guys, okay? I'm gonna get rid of the, I'll leave the 16 and the 17. So 0, really, I'm gonna write all of these as 4 digits. So let's say that I have $2. Is that the same as $2? Absolutely. Same as $2? Absolutely, right? So I can put zeros in front of everything. It doesn't change the meaning of it. So I'm going to put all of these as 4 digits. So now look at something interesting, right? So in binary, the first position is the ones. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. They change every 1 time. Look at the second position out is the 2s, right? 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. They change every 2 times. Next position out are the 4s, right? Remember, 1, 2, 4, 8. So third position out is the 4 position. If I go to the third position, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. They change every 4 times. Next position out are the 8s. 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1. They change every 8 times. Interesting. Okay. Now, there's another way that we use to represent numbers. So check it out. When we talk about binary numbers, we tend to group them in groups of 8. So basically when we have one digit equals a bit, like Bitcoin. 8 digits is a byte. Okay, so when we send stuff in like via computer, we send it in groups of 8 bits or a byte. And that's because on a keyboard, all the characters on my keyboard I can represent with 7 bytes or 7 bits, sorry. And then I have an error check. We're going to learn how to do error checking on this. That'll be my final byte. So basically, if I have 1 byte, I can represent everything on a keyboard, so it makes it easy to send characters. So in computer standard, everything is sent as 1 byte. Okay, so check it out. Each of these is a half a byte of 4 bits, also called a nibble in computer terms. So if I am to communicate a number to you guys, right? If I need to communicate 01011101, it's not easy for humans to remember that we get that kind of mixed up. So it'd be easier to say something like 89. We can remember 89 and then we convert that out. But that's going to have an issue because if I say, let's say I say 112 or 112, right? Okay, so is it a 1 followed by a 12, or is it a 1 followed by a 1 followed by a 2? So basically, to be able to communicate 4 binary digits as 1 character, I could communicate 0 to 9, fine, but 10, 11, 12, 13, 14, and 15 has 2 characters. So to communicate, for humans to communicate binary numbers, we often use the hexadecimal system or the hex. So hex is base 16. So that means that each digit can be represented by 15 different characters. Okay, so hex is pretty easy. So in hex, 0 is 0, 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6, 7, 8, 9. Now when we get to 10, they just use the alphabet. A, B, C, D, E, F. Okay, when we go above 16, this would be like 1, 0, 1, 1. So basically, 14 in our number system is 1110. In binary is E, the letter E, in the hexadecimal system. 7 in our system is 0111. In binary is 7 in hex. All right, so I'm going to make another video where I show you how to convert back and forth, but this explains kind of like what is binary, how does it relate to our number system, and what is the hexadecimal number system. So I hope that makes sense to you guys. There's probably lots of YouTube videos on how to do it.